to a YouTube channel named SD CPP MU. MU stands for Meetup. I actually received this in mail today. This is the newest third edition of Bjarne's book. Just received that. So I didn't have a chance to look at it, but hopefully it's good as the previous ones. So people are trickling in. I wanted to share a few things before we start. First of all, I was attending the CPP Con in Colorado, in Aurora, which is basically very close to Denver. Was very good this year. It's the third time that I'm attending the conference, and good speakers, good atmosphere. I think meeting everyone after 3 years. I think last time was 3 years ago that I was attending 2019. So it was great meeting everyone, and a lot of talks. If you're coming from Qualcomm, there is for every day I had a write-up. It's pretty long. I know it's lots of things to read, but if you need the write-up and the report for every day, so there are 5 different write-ups for each and every day of the conference. So it's there in the MS team meeting. I think it took me maybe 45-50 minutes to write each one because it was like a lot of things to cover. So that's one thing. Again, it's recorded. I'll start sharing. Actually, I am already sharing. If you're new to the meeting, first time attending, don't worry. We'll take it baby steps for you to kind of understand what we have here. Okay. So welcome to the 42 meeting. We're running it for about 3.5 years with just 1 month break when the pandemic started. I thought it's going to be just one month, and it didn't. So I moved from in-person to virtual. There are requests to start having in-person, and I still need to work on it. The venue is usually a problem, but Qualcomm is already hosting the Python meetup, so maybe we can follow up on that and see if we can copy what they have as well. If you wanna comment on anything, feel free to just stop me and ask questions or comment or whatever. That's fine. It's completely kind of free form. Nothing is really official or it's just basically casual. So feel free to ask anything. Do you see the agenda right now when I'm flipping?
Yeah, we see it.
Yes, we can see it.
Perfect. So this is the agenda. I start with the welcome slides. We tend to have new people coming in every month, so I want them to feel welcome and they understand what we do here and what are the goals, and hopefully they can come in the future and maybe sometimes even present. So everyone can present, taking small or medium or large topic and just talk about it. It's the goal here is really to learn and share ideas. That's the idea here. So we will have a few CPAPAS quiz from the CPP quiz website, and then we'll talk about template function specialization. Actually, these two, I'm just saying I was copying the agenda for previous time. Actually, just ignore these 2 bullets. We're gonna jump to the range for loop. There should be a book. I don't know what happened here, but there should be a book, and then only there is a range-based loop. So just ignore these 2. There is a book, and I have something regarding the book so that they might make you happy. Okay, so welcome to the new members. If you are a new member, welcome. Pretty happy to have you here. Again, the goal here is to exchange ideas. There are so many things that we can extract from sessions that are online, blogs, books, endless. There are really endless ideas and things that we can extract from anything out there about C++. And there's a lot of drama also happening to this time around with C++ about all kinds of successor languages that are popping up. We can talk about that as well if people have questions and want to have discussions. That's also something that we can have. Uh, the meetup is sponsored by Qualcomm, which I'm part of, the wireless department software team. So thank you, Qualcomm, especially Charles Bergen, which is my VP and supporting this meetup. So thank you, Charles. We have a Dropbox link that I copy all the material back to the Dropbox when I'm done with the session. We have a Slack channel and which I'm not really using, but it's there. And we have a Discord that is kind of sometimes dormant, sometimes people ask questions. But if you need an invite, just ping me via the meetup page, or if you are in Qualcomm through the IM in MS Teams, and I can get you a new invite link if this doesn't work. We have a YouTube channel, SDCPP Meetup, where you can watch previous sessions that I uploaded. I have a handle in Twitter, which is SDCPP Meetup. I have my own handle, which is Kobe_CA, and I tweet about obviously C++, Linux, software engineering, sometimes Rust, sometimes Python, but basically these are the topics that I'm tweeting about. I'm sometimes writing in a blog that hosted by Martin. This is the blog ID and that blog URL, so you can jump to that. There's a lot of information for Martin that he accumulated throughout the years. Okay, so the first thing in the agenda, which I didn't put in this on the slide of the agenda, which should be, but it should be in the actual in the invite, is the following. Sometimes I get to read a very good book that I would like to recommend, and this month, this time around, I would like to recommend the one that Marius published through Packet, and this is the name of the book, Template Metaprogramming with C++. And uh, first of all, it's not the first book of Marius. He had few of them. All of them I've read, and it's really good, really good books, very well written. I highly recommend to check it out and own either the ebook or maybe the printed one. Lots of good material. This specific book is that was just published is talking about templates. Obviously using more than C++ concepts, and I have a few of the things that he has in the next slides. It's a very good material if you're interested in understanding templates from the beginning all the way to very advanced topics. So this is one of the books today in the market that would have a very detailed explanation about templates, comprehensive one that I'll definitely would recommend to pick it up. This is the back cover of the book, which tells about. But I just decided to. I just flipping through the book. I kind of extract the things that kind of I wanted to highlight. So introduction. So unlike other books that might talk about templates and metaprogramming, basically metaprogramming, it's something that we kind of discourage of like saying metaprogramming. It's basically generic programming, not meta, but generic programming. That's the newer approach of saying things. It's basically a way to write code that generates more code. So the compiler basically reads the code and generate types and functions and so on and so forth. So this is a very good. It's a very good book for introduction. Then it start talking about variadic templates, which introduced in C++ 11. Forwarding references that are in the context of templates. There is a very specific handling when it's come. If you don't know what's forwarding references, don't worry. You can pick up the book or just Google for that. Dependent names. So if you have a specific template parameter, everything that depends on this template parameter is a dependent name. Recursion with templates. CTAD. This is the new thing where you can say stud vector space and then initialize vector with 1, 2, 3, and stud vector would be int. So it's a compile time argument deduction of the template. So it's kind of confusing because if you're looking at stud vector, you know it's template, but you don't need to specify that it's an integer. If you have information that the compiler can deduce and understand that this is a stud vector of int. Type traits, a very important and very basic thing in kind of a building block for a more advanced template generic programming. Sphena, which I'm not going to talk about right now. It's a more advanced concept. Const expr if, which was introduced in C++ 17, if I'm not mistaken. Concept, C++ 20, constraints class templates. If you're coming from other languages that have generics and constraints, this is very, very similar. Dynamic versus static polymorphism. So usually templates are kind of associated with static polymorphism. CRTP, the cursory recurring template programming, which become a much more simplified pattern in C++ 23. Again, it's a big topic. I think we touched upon it sometime in the past. Type erasure, a very important concept, also in the context of templates. Tag dispatching, which makes generic programming very clever and efficient. Type list, ranges algorithms, and iterators, which are basically kind of a building blocks for composing software. And ranges library, which is the stud ranges that comes from the ranges v3 library. So you can just see by just looking at the list that this is a very, very good and comprehensive list talking about everything that you can think about templates. It is 480 pages, and I've just read really few of the chapters, but I flipped through everything so I can actually talk about these details. Okay, so here's an example that the book would have. So, for example, if you're coming from kind of the beginner side of C++, so this is an integer type of a function. There is a double instead of having an int and a double. This is how you actually use templates. And in C++ 20, we have a new way to write templates, and this would be the form of the new. So you don't have template type T, but you have auto as the T parameter, what used to be T parameter, and you have auto, and then in this case, const A is the parameter and const B is the other parameter. Okay, so Packet actually, I can't even remember how they approached me, probably through LinkedIn and all, and they asked me about the book, and I just happened to say, okay, I actually planning to have that as the book of the month. If you have a Packet publication account, they want to give away 5 ebook copies. This is my Twitter handle. You can just IM me through Twitter. The first 5 that would IM me just will get the ebook copies. I'll just take after the meeting. I'll just pick the first 5. That's just by order, and I'll ask and I'll forward that email to which use your email that you have for the Packet Pub account. I'll forward that to the Packet Pub guy that contact me, and he would add this ebook to your account free. So hopefully you can make use of that. Again, if you have any questions, please stop me. Okay, so if you remember, I'm gonna have 5 C++ quiz and then one topic about object lifetime in a for loop or basically range-based for loop. So this is the 2 things that we're gonna have today. And I believe, what's the time right now? It's 5:14. I believe by 6 p.m. Pacific time we'll finish the meetup roughly. So let's start with the first one. And again, if you have any questions, just stop me.
Kobe?
Yes.
Excuse me. Thank you. This is Nicole. Thank you very much for accepting my request to join your meeting. As you know, I am here new. I'm a new person, and I may have missed the part of your agenda when you asked or suggested that people introduce themselves. It was going pretty fast, but thank you very much. I'm really very glad to be here among the C++ intermediate, beginner, advanced. I'm not sure. I have a brief moment, please, if I may, to talk about
Sure.
thank you, before you jump into your quiz. I'll make it quick because I heard you're trying to watch your time for this meeting. For you and everyone listening in the group, I have a diversity learning app. I guess some people call it a digital product. Software engineering, IT, computer science is not my field, but the diversity learning app was written in C++, and so that is why I'm here. It was also written in SQL, Java, and some other languages, I believe, and it was tested by a small business in Del Mar in about 2000. And I'm here because we need someone or someones to update this app so that we can start using it again. Again, this is for diversity and learning. And we just are looking for someone who, is easy enough to work with, kind of consistent with what you said this meeting was about, kind of free form and casual and so forth. But we definitely are interested in someone who's absolutely qualified. And I was really thrilled to hear that this meeting is sponsored by Qualcomm, because I was wondering, is it sponsored by Qualcomm or UCSD, or who are these experts, where do they come from? So I was very happy to see that slide. So if anyone is comfortable doing, I think it's intermediate or advanced, I'm not certain, but it's pretty straightforward since this is just an update to an app, and I would love to talk about it more. So and if anyone's listening and able to do it or know someone who's able to do it, please contact me. My email address is greetings at pearledei.com. That's PERLEDEI.com. And I believe I'm also able to be contacted through this meetup group. I'm not certain how it works. Kobe, you can
you
help me
can
out
do
here.
that. I believe if you put a message, everyone can see that. And since
Okay,
you're a
great.
member, I think there is. If you have any issues, just don't hesitate to just let me know, and I'll help you to promote that.
Thank
And
you very much, Kobe.
yeah, and I now remember you actually contacted me a few weeks ago. I think
Yes. But
yes,
you told me you were busy. You told me you were busy, and
I'm always
you
busy.
would let me know. I know it sounds like you're very busy. I was listening. I've been listening the whole time about the conference and all that. So I don't want to take up any more of your time, excuse me, but thank you very much for allowing me to introduce myself. And it sounds like a very exciting group, and you've been going on for quite some time, and I really appreciate being here.
Thank you, Nicole. I appreciate that, and I apologize. My memory was not up to date with. So thanks for chiming in. And if someone wants to contact Nicole and didn't get the email and all, just either through the meetup I am or just through me, I can definitely help here. Just let me know. And is there anyone else, by the way, that would like to introduce herself or himself or themselves and just chime in and say something about the meetup, maybe what they expect to have. I don't know. Today it's a bit too late because I already have material, but maybe in the next sessions, if there's anything that you would like to see, anything that you would like to learn, I'm okay to have a discussion before I jump into the meat of the meetup. Don't be shy, by the way.
Thank you again, Kobe.
Yeah, sure, Nicole. Thanks. Anyone? You want to see the quiz? Huh? Okay. I'll take that as yes. We want to see the quiz. Okay. First quiz, number 49. So if you're new to this is the cppquiz.org. There's also an app. If you're bored, there is an app on your phone that you can have that. There are 4 options. Either there is an output guaranteed by the standard, or there is a compilation error, which I almost never saw a compilation error, by the way, but maybe today. It's either unspecified, or implementation defined, or it's a non-defined behavior. So there are 4 options here. So take a look at that, and I'll kind of talk about the construct, and then you can think about the options here. Okay, so we have a C class that is initialized with C1. So there is an instance of C that is initialized. There is a constructor that takes an integer. So I is bounded to I here. And there is a stud C out here. And we have stud C out at the end of the instruction. Then we have C2 and C3, which looks very, very funky, but it is what it is. What do you think would happen? You can shout the solutions that you think would happen.
If it's not guaranteed to output, I'm guessing first. Can you hear me all right? This is Aaron.
I couldn't hear someone. I couldn't hear, but I don't know if it's on my end or.
What about now? Can you hear now?
Now it's better. If it's the same person, yeah, now it's better.
Okay, sorry. So if it's not guaranteed to output just the kind of what you would expect, I'm assuming it's because the first object is a reference. Maybe something goes weird there, but I'm not sure what as yet. That's just a first thing that catches my eye.
Okay, so let's take it one line at a time. So first of all, it's a question about destruction and construction when it's happening. Plus, we're talking about lifetime here. Okay, lifetime is always a hot topic in languages, especially in C++ and other languages like Rust and other languages which are not GC languages. So let's take a look here. So C1. So we have an object that created. Everyone agrees, right? So since we have an object that created, we created with 1, so we print 1. Let's try it. Okay. When do you think this would be destructed? And what happens when it's destructed? When it's destructed, it would be 1 plus 5, right? So it would be destructed sometime. We don't know exactly when. The fact that we have here a const reference to a temporary, if you know the rules of the standard, it would prolong the lifetime of this object all the way to the closing scope, which is this. So sometime in the future, this instance would be destroyed and would output 6. So we have something, and I deliberately put it at the end because it was created first, and it's going to be probably destroyed at the last one. Okay, so
that can also get you into problems too with the lifetime extension because it's not transitive. So you can take that extended lifetime, return it again as a temporary value. Where that thing is expecting to extend the lifetime by lifetime as well, but it won't because it will still be destructed when the first time goes out of scope.
Yeah, but we don't have it here though. Here it's pretty simple. You're right, but it's pretty simple here. Okay, what happens with C2 and C3? It looks funky, right? We create an instance, and what happened immediately? It's destroyed. There is no real meaning unless there is a side effect in here. Is stud C out, but it looks very funky. So we'll have 2 because we're creating and then it's destroyed immediately, which would be 7 because 2 plus 5. And then we have 3 and it's destroyed. 3 plus 5 would be 8. And then, as I promised, 6 would be the last one. Like this would be the last one. Let's take a look. Now, the idea behind CVP quiz is that the whole idea is to understand, by solving this quiz, you maybe understand better the some specific element or feature in the standard. Here, it's basically, there are a few things here that we should take away. One is temporaries, which are bounded, we bind it to a const reference, lifetime extension. We talk about lifetime extension, by the way, shortly. It's going to be a lot of fun in 15 minutes. Then we have this funky C2, C3, basically creation and destruction, That's about it. And it says here very clearly that temporaries returned by C2 and C3 are still destroyed at the end of their lines of creations. They get destroyed before the one, which is C1, which is going to be the last one.
Right, one question there. So,
Yeah.
Is it guaranteed that C2 would be destroyed immediately before the C3 is initialized?
Otherwise, the output would be different. So
Right.
that's why I said it's going to be this constructed destroyed. Okay, in this case, this specific case. Otherwise, the printout would not be, because we have the destruction. So we have 2 and 7. 2 and 7. This is why if you have 7, it's because 2 plus 5. So the destruction happening.
No, that's not my question. Is why would that be the case? Isn't that supposed to be the end of the scope that should invoke the destruction of the object within that scope?
Yeah, not there. There is no variable here that would capture it. Right? The destruction is called. The way you should look at here is that there is a construction and there is the destruction happening, because there is no, it doesn't bound to anything. It's not binding to anything. You see, they are destroyed at the line of creation.
17, or is it
Sorry?
in general?
No. This is in general. Always been like this.
Okay.
These are the rules. It's like I'm not making the rules. These are the rules. It's the end of the expression. They're going to be destroyed. They are not bound to a variable that would be on the stack. There are temporaries that would be destroyed at the end of the expression.
Suppose if it is assigned to another object, or how should I
That's
say
something
it?
else. Yeah. If they are assigned, then you have something on the stack.
Okay.
This is a reference on the stack, and this is going to be prolonged all the way to the end.
End of the scope. Okay, got it. Thank you.
Would the output of the program be the same if you omitted the const keyword?
If you don't have the const, it's actually a good question. If you don't have the const, it's going to be a compiler error. Why? Because since day one of the C++ standard, you cannot bind an R value to a non-const reference. In C++ 11, we have an R value reference that makes it possible to bind the reference to a temporary, basically an R value.
What may be causing a little bit of confusion, I think, is that const is referring, it's making the reference const so that it can't be rebound to a different reference.
That's correct. It cannot be rebound to a different reference. I'm trying to increase the size. For some reason, it doesn't let me. Oh, okay. So this is the output. You can see it here, and I'm going to remove this is C++ 20, but I can make it anything here. Just ignore the 20 here.
It seems that without const, it still works even on earlier C++ standards.
It should be a compiler error.
Oh,
The reason it is a compiler because you cannot bind an R value to a reference, a non-const reference. Same deal if I had a function here.
I don't know why mine's just working fine, compiling and everything.
Yeah, that would be a violation of this. I don't know which compiler
But,
you have you copy paste this one and it's working.
Yeah. Well, yeah, that's from what I see. I'm using the x86 Microsoft Visual Compiler.
Okay, let's take a look at Microsoft Visual Compiler. Okay.
Yeah.
Which one? This is something,
Just
by the way, from the early days of the language. It's not new.
think
MSVC what?
x86 MSVC v19 latest. Yep. Oh,
MSVC
there
latest.
it is.
This one.
Yep. Yep.
Interesting.
It's yeah. Hmm.
Yeah.
How's
I
that
think
how is that
from-
possible?
Yeah, it's my recollection from, I've been using C++ since 1990, that in the early days too, and maybe persisting, some compilers treat it as implicitly const, and you'll see an error come up if you try to rebind it at any point later.
This is, I'm not using MSVC. I'm using Clang. Like if you look at Clang would have the same behavior. This is kind of this is very interesting. Thank you for pointing it out because I'm gonna
What about the
have lots of
GCC?
fun tonight with others.
Can we try the GCC?
GCC we already had. GCC.
Oh, you did? Okay.
Yeah, this is really fun. Okay, MSVC, not one.
Try it times 8664 MSVC.
MSVC, which one is it?
Times 64, the latest, instead of times 86. Yeah.
This one?
Yep. Don't know. Yeah.
Interesting.
Seems like it's a Microsoft.
No, but it is violation of the standard. The whole idea was that you must have a const reference. This is by the standard. It's really interesting. Okay.
Oh, can we try one more thing? Like, can we try what James suggested? Like, can we try it to another object to see if that throws an error?
I already tried it. It doesn't throw an error. It rebinds successfully.
To what? Say again. To which one?
Yeah, no, James was saying there could be a possibility that it could implicitly put it to const, right? So that also doesn't seem to be the case. So
can you hear me?
Yeah, I can hear you. Yeah.
Okay. Can you do the /permissive minus flag on the command line for MSVC? Permissive minus. Yeah.
Like this?
Yeah, I think that would be the closest equivalence to, yeah.
Interesting.
It's slightly more pedantic. I guess the equivalent of dash pedantic.
But you see, it's not about pedantic or not pedantic. This is a language feature.
Yeah.
It's a Microsoft extension. Oh, here's the permissive minus for standard compliance. Okay. Thanks God, I'm not writing it with MSVC.
Interesting.
Oh my God. Oh my God, this is really fun. Thank you for pointing this out because this is really. I've been doing C++ for 23 plus 24 years. Never this is something that is really hardwired in my brain. Never had that. Never realized that this is actually supported in, deviated, I would say, in Visual Studio. Oh my God. This is fun.
The old days of Visual Studio when it really was a crap compiler.
Yeah. No, look, this is insane. Okay, so I'm not gonna have the examples that I have because it's moot. Okay, we learn new thing today.
This is an example of an embrace and extend from Microsoft. Which they've done in other languages as well.
It's insane.
Embrace
Okay,
and extend from the end of a rope.
Yeah.
but please don't do. By the way, please don't do that.
Yes.
If you
yes, I
have, if
agree.
you have a temporary on R value reference, but oh, what I wanted to show is that this is the the new thing that is supported, which is we have a new reference in C++11, which is an R value reference. Now we can bind it to a non-const and prolong the temporary just like before, but it says this is a reference to an R value. Okay, this is not a forwarding reference, just a regular R value reference. Okay, I think I'm gonna have just one more quiz and we go to the other topics, so we have time. And if we have more time, I can have another quiz or two. Just want to make sure that we frame it in 1 hour. Again, thank you for that. That was a great discussion. I learned something new today with MSBC. Okay, this is a harder difficulty, which I'm sorry about it. Again, 4 options. Take a look at that and think what can be if there is an output. This is again something related to lifetime. And some hot topic. Okay, let's take a look what happened here. There is an integer main that returns integer, just the main function. There is a try and catch. We have a try of foo, which is this function. Then we catch. If it throws, if something throws, we'll catch it. We print C, call foo again, and end the program. Let's take it one step at a time, okay?
So I think the first try will cause the exception to be thrown from A.
Okay. So let's see why. Okay, so because I don't remember I don't remember actually. It's been a while since I had this slide. Okay, so so we call foo, which have static b, which creates b. First time we enter the function, b is initialized. So let's take a look. B is here. So b has a member a. So before we enter to the constructor, these are the rules. Before you enter the constructor, your base class, your members needs to be initialized. Okay, so let's initialize. We don't have a base class in this case. There are some questions, by the way, with base class. We don't have it right now. We have A. Someone already mentioned that it's gonna throw. Let's see why. So we create A. So this is A instance. We don't have members. So let's go into the constructor. The hint, by the way, that I want to give is that if you throw from a constructor the object as if was never constructor, there is no object, there is no destruction because there was no construction. Only when you hit these curly braces, without exception, the constructor is completed and there is an object, there is an instance of this object, of this type. Okay, so so we create A, so we enter here, we do std out A. So I pretty much can say that A will
be printed, yeah.
Okay. X is 0. X is global. Globals are good. No, I'm kidding. Globals are not good. Don't do globals. So, but for quiz, globals are great. So we have this X++. So if X++ is equal to 0, so X is 0. So we first compare it to X compare X to 0, and then we do plus plus. So X would be 1 after this expression, but compared to, so it is 0. So someone already said we're going to have exception. So this person is correct. So we're throwing the exception that was coming from here. Let's unwind the stack in our head. It started here because we're creating the instance, and the whole thing started with creating B, which comes from here,
So again, is it fair to say that B also will not get created because A did not
This
get
is
created?
yes, of course.
Okay.
Of course, because we didn't end B. We didn't hit this one. So there is no A and there is no B. Okay. So we catch. We throw stack unwinding, catching, stutz out C. Let's print C. Okay, now let's call through again. So let's call through again. Do we need to create B? Yes. There was no B. So let's create B. So again, before we hit this one, we need to create A. Let's go to A.
So A will be printed again.
A will be printed again. X
This
is
time
1.
X is 1. Yeah. So there will
Perfect.
not be an exception.
We end it here, which is here. Let's go into the constructor of B.
B will be printed. Small b.
Let's exactly. Let's print B. So it all started with this. So we have B. We have B. Inside we have A. All is good. We are done here, and we are done here. What happens at the end of main?
First, probably destructor of A will get created, called. So like capital A and then capital B.
It's actually the other way around. Capital B, capital A.
Why B and A?
Well, generally speaking, that's the way I understand it. It's like, you know, the order of destruction is the reverse of the order of construction.
Exactly.
I'm not sure because that is for derived classes. This is not a derived class.
No, it's every destruction is the opposite of the construction. Okay, I don't know if they're every. I should be very cautious with the word every. In this case, what happened here is that we enter the destructor of B, and remember we created A before we created B. Then we destroy B and then destroy A. Let's see if we correct. And this is the correct. And it says here, when main exits, the static variable B is destroyed, which is this one. First calling the destructor printing B, and then destroying member variable, which is printing A. So remember the fact that, which is really confusing, but just remember that. If you are in the destructor, you can still work with your members. Your members are valid inside the destructor. When you end the destructor, this is where your members start destruction order, which is reversed to the construction order. It's very simple. So if we add A and I don't know, like X, Y, and Z, be Z, Y, and X, the reverse order of the members would be destroyed. The interesting, yeah.
I was going to ask more so about static objects or static variables in general. I believe those reside in read-only memory. If it's, I mean, I might be off here, assuming it's const.
This is not a read-only memory. There is, I forgot the name of the section.
And in fact, yeah, you can change it in the test, right? So
yes,
you can change it in the program.
Yeah, they are in. I forgot. Slip my mind. There is a global initialization or something like that.
Something like that. Yeah.
I can't remember the name of the section, but in this case, they're not read only.
Was it the BSS section?
I can remember. Someone can Google that and let the entire group. I can't remember the name of the section, but it's a different section. It's got like global initialization or something like that. I can't remember. Or static initialization or global initialization. There is a section for this kind of initialization. By the way, just FYI, if it was a pointer, it would be initialized to value initialization, which would be null pointer. If it was an integer, it would be 0. You can still. I tend to explicitly say, okay, 0 equals null pointer if I want to initialize it, although it's being guaranteed to be initialized. Okay, by the way, there is a very nice book from Jason Turner on initialization. Oh, I should probably point that out. Jason Turner.
Oh, is it the lifetime puzzles?
Yeah, it's a very good one. Okay, let's see. So he has it in, yeah.
Sorry, just to interrupt it. At the very top of that code, we have index equals 0. Would it have been better to use const expr int I equals 0?
Let me go back. Let me go back. So this is not this one. This one. Const expr. It's a const. We change it here.
Oh, right. Okay, thank you.
So this one, it also has a printed. I actually have the printed also because it's really useful to have a pen, actually a pencil that you can erase, and it's really nice. So it's also available in print here. It's like $10, I think, or something like that, if I'm not mistaken. Last time I checked. Yeah, it's $10. Okay, and it has also copy and reference and opcode puzzler. So he has 3. Very recommended. It's pretty fun. If you wanna exercise this whole thing, it talks about this exactly type of exercise. It gets very, very hairy and very, very big towards the end of the book. Okay, so
a question, Kobe.
Yes, I'm listening.
The same. Oh, could you share again, please?
Oh yeah. Sorry, 1 second.
So my question is, what if we do exactly the same thing in the A constructor in the B constructor? So when it throws the exceptions, would an A already get constructed? And then since B is throw exceptions, it won't go into the destructor. Then what about the A's destructor then?
Okay, so you need to remember that everything that was constructed would be destroyed. So you're saying when we hear A was already constructed in the second time, right? In the second time, and
Correct.
then you throw here.
Yes.
So B was not constructed, but there is an A, so there was going to be an unwinding of everything that was already fully constructed.
Oh, when? Since there is no destructor for B.
Oh, it's a good point. So basically, there is no destructor for B. So you're saying, okay, the destructor is not invoked. So who's gonna invoke that? Which
Correct.
is a very good question. Actually, I have Godbolt here, so let's do that. So let's do let's see, let's do it before. See. Okay. So let's see if I made something which is answering your question. This the second time it's gonna come here, it's 1, so it's stood exception. So before that, what did we have before? Before that it was A, C, A, B, B, A. Okay, first of all, I don't want that. MSVC, that's it. I'm done with MSVC for today. Maybe in the next lifetime. Okay, so this is the okay. And this would be, so X is 1, so it should throw takes a long time. Still not done.
I think it will it will terminate the program since we don't have a catch.
First of all, yes, but it doesn't say anything here. So I need to rethink about that. when B is invoked again, this would be thrown from here. I wonder how.
You can always have problems with the output IO functions because your termination of the program with the exception could happen before the IO buffers have been flushed.
Yeah. Just trying to see if there is something optimizer can. So it looks like it's the same. Doesn't make sense though, because we're throwing on the second one, which should be here, right? Everyone agree? Yeah, I don't know why it behaves this way.
What happens if you throw from B on the first one and don't throw from A on the first one?
So you were saying comment this one?
No, I think that
yeah, that's
that's
what I meant actually.
So
that's fine because the second time it comes into B, X should be 2. Because first time you call foo, X goes to increment goes to 1. It throws an exception, returns. Next time you call foo, again it goes into A construction, X goes to 1. And you're comparing in B with 0, so it's already 1.
Yeah, it's a different output.
Yeah.
But it's still so let me do so it's already 5:50. I wanna go to the next few slides. Let's do this. I'll play with it more and I'll revive Discord. So we can chat about Discord. If someone wants to already take a lead on that either tonight or tomorrow, and I'll catch up on Discord on that one. It's an interesting question, Chester. I'll take a look at that. I can see why it's not obvious that it would throw. I would think, but
Thank you, Kobe, as always.
no worries. Okay, so let's do this. Let's move to the next part, which I promised. Actually, let me share first. Machine is super slow. Okay, thank you. Okay, can you hear me?
Yeah. No, we
Yeah,
can.
yeah. The call was dropped. Actually, I don't know if the recording is still. Sorry, my machine stopped working and everything just crashed.
Looks like the recording is still on. Yeah.
Recording is still on. Okay, awesome. Okay. I'll try to share again. Maybe turn off the camera. Make things easier for my poor i5 machine. Okay. So let's talk about temporary object in range-based for loop. Why it's so hard, and what does it have to do with lifetime, object lifetime? So this is a pretty hot topic, and let's try to sort it out. And hopefully after this session, you'll be expert in this whole idea. Okay, so we have this Stack Overflow question. This person asking why this is crashing both in Visual Studio and GCC. It requires a range-based for loop. So let's see what happens here. There is a struct S that has a stud map. A stud map is basically, and this person is using namespace std declaration here, and just stud map is basically a binary tree in the standard library, string to string. So there is a pair of each entry in each node, and the constructor is creating a key. And what we have here is that when we accessing, when we have this function call, it calls a string, returns a reference to a string. And it says here that this is crashing. So let's see what happens here. We have a call to S. It's basically creating here. What do we create here? Create here a temporary, right? And we call a function in the temporary, getting a reference to some element that resides in the temporary. But and then we want to iterate, just print the characters one at a time, but it's crashing. So let's see what happens here. So first of all, you should understand that the for range loop has it's basically, and this is something that you can take a look at CPP Insight. It looks like this. There is no life extension of anything but the final temporary, if any. Anything that is beyond that temporary is discarded before the for loop. And we'll talk about it in details in the next few slides. So basically, this is how it looks like. It looks very intimidating, but this underscore just how the standard library is using. This is why underscore is reserved to the standard library. I'm gonna jump almost to the end, but kind of a rule of thumb is that if you have a temporary, there are a handful of operations that you can do on this temporary and bind it to a reference. And the last thing that you do on this temporary, that something or arrow something would still be alive. So there are a handful of them. If you have an object and you call a function on this object, which returns something, and this something is a reference, it's not a copy, then that function, I call it like a second level call. This second level call is not extending the temporary. If we had just S and we bind it to some reference, yes, this is the first level. But when you do another operation, at the end of this expression, S is gone, and everything that relates to S is also gone. So if this function takes something from the temporary and it's a reference to this, it's gone. And the compiler doesn't really help you. Some kind of a small comment here that compilers, actually today I checked that they sometimes give a diagnosis about, okay, be careful, you're actually looking at dangling reference. Let's talk about how to fix it first, and then we'll understand more about what's happening here. So this person has these two examples of how to fix it, and by understanding how to fix it, we understand what the issue is. So first of all, this person has this option. It's using the option that was introduced in C++ 11. So you can decorate. I don't know if decorate is the right word, but you can decorate. I'll use decorate. You can have this decoration of the function at the end by saying either it's a reference or ref. When you have something which is a reference at the end of the function, it means that the compiler, when it holds a specific instance in compile time and you do .func, if this function if this something that you hold is an L value reference, it's something that is not a temporary, it has an address. If this is something that is an L value reference, it's going to bind this call to this function. Otherwise, if you have this ref and you're holding a temporary, then you are binding in compile time. Nothing here is in runtime. It's a compile time, because in compile time, the compiler knows if you're holding a temporary or not. So in other words, if you have s.func, and this s is a temporary, so it's an R value reference, and if you had the solution done this way, I'm not talking about C++ 23 deducing this. If you coming from a very advanced C++, just ignore it for a second. But if you have this option that you're writing, which means I want you to bind this function to an instance which is a temporary. So in our case, when we have s instance as a temporary and we call that function, we are going to call this function. And if you notice, this is a std string by value versus this one is a std string by reference. Since we are calling on a temporary, we don't want to return a reference, but we wanted to return a copy. There is some optimization here that someone says, okay, instead of creating a copy, I'm casting it to an R value reference and I'm moving it. That's another level of optimization, but I could actually just have m.find second and just make a copy. Once you make a copy, everything is good. There is no issues. Once you have, if you have no other options, just make a copy because you have no options here. If we had an s, so if here we create s outside of the for loop and then have dot function, with this solution, we would call this function and then we can return a temporary because s would be alive all the way to the end of the scope. Okay, let's take another example. Okay, so thanks to some segmentation faults and warning in Valgrind, I found out this code is incorrect and has some sort of dangling reference in the for range loop. By the way, when you have an issue like an undefined behavior and it doesn't crash, this is a bad thing. You want it to crash if you do something bad. Valgrind is also something that can help you with that. In this example, there are segmentation faults and Valgrind also provided some help. And I'll show you another in the next slide. There's also another help from the compiler. But let's take a look what's happened here. There is a function that returns auto, which means it returns something that the compiler would deduce. It's std vector in this case. So we have a vector of vector. So we create an instance of this vector of vector. We create 10 instances of std vector of double. Each of them, if each inner would have 3 doubles. Then what this person is doing, the person that actually wrote this, it takes iota. Iota is basically takes a range and populate it from the first value all the way to the end of the range. So it's going to be 0, 1, 2. So it just takes, just for this example, it takes the 5th or maybe the sixth, I would say, because it's zero based, the sixth vector, and populate it with 0, 1, and 2. And then returns this vector, this whole vector. It's being returned. It's being returned from here. So we call this function, and then we get a vector back, and we call a subscript operator, which is a function, by the way. So you already know from my previous slide or slides that there is not a single level, but there is another level. And as I mentioned, another level doesn't extend your temporary. Just keep this in mind. And it's the very last slide. I have some summary that Amir Kirsch was adding to one of the Stack Overflow, which I think is a very good summary. So we already know that this is not going to work. And it says, of course, a way to avoid it is to call this. So what happens here in this line is that this person is calling f, extract the sixth vector, which just happened to be populated here with 0, 1, and 2, makes a copy. Now everything is good. Okay. So what happens here? So first of all, I just happened to put it in cppinsights.io just to see how things would look like. And even before I actually looked at how the code is generated to kind of present you, trying to explain how things happen, what happens here, I noticed that there is this error, W dangling GSL. And I actually was this one has an LLVM Clang backend, this website. I was very happy to see this error. It's coming from LLVM, so this is really nice. So it's already telling us that this is an issue. Let's take a look at what actually generated when we put it on CPP Insight, clicking play. Okay, so what happens here? So there's a lot of boilerplate code that, because std vector has two parameters. One is std vector of what? What is the type? Plus the allocator. So it looks very funky because when you see what the compiler is actually parsing, it is with the allocator. So it looks like a very, very kind of long line, but it's just std vector of vector. Just every vector has an allocator. Okay, so this is the first thing. So we return v. V is a std vector of vector. So this is auto. This whole thing is what the compiler actually sees. And f is the function name. Open curly braces. Std vector, again, std vector of double allocator, and then std vector, double allocator, and so on and so forth. And I don't show here, but it's a very, very long line of initializing it with three elements. Then we have iota, std iota, which takes v dot operator, begin to end. We have range and 0, which would be the first value to populate. Iota is really, really handy when you have a range and you want to populate it from a specific value all the way to the end of the range. So it's very, very useful. And then we return it. Okay. Now the range for loop that we got from CPapas 11 is being actually parsed this way. We have this reference to f operator, subscript operator 5. So we have f that returns a vector, and then we have this operator, subscript operator that is that is kept in a reference, and then we have a begin, we have an end, and we just do this for loop. Okay. Any questions so far before we go to the next slide? Okay, just remember that f returns a temporary, right? And then we do something on this temporary. So it's the two levels that we operating on this temporary. Okay. Using a temporary as a range expression directly is fine. The lifetime is always extended. The problem is this the only one, or do we do more things on this temporary? What f returns is a temporary and it's constructed within the expression. It will be destroyed after the whole expression where it's constructed. So f, it's hard to see it, but f is destroyed here in this semicolon. And everything that is relating to f would also be destroyed. There is no extension of the dot operator, whatever dot operator subscript is returning, which is a vector. Okay, so this person that replying saying their poem might be walked around using an init statement. Okay, so you have this. So for example, the way it's being used here is the following: you have auto thing of f. Now you're holding something with thing, and then you can basically do thing something. Okay, so this is gonna be gonna work well. And this is another view of what's happening here. And this person that actually replied started hinting towards, okay, what does it work to? And this is something that I want to expand more. To add more wrinkles, there are other cases where indirect binding would still do a lifetime extension. So here's an interesting thing. We have foo that returns an x. We don't even need to define or implement this foo. That v is a vector, and it works fine. Okay, so why? I just said that there is like a second level would not extend. Now it depends what does it mean second level. There are few operations, and this is one of them, that are, I would say, kosher in the sense that they can extend the lifetime. So they are not actually they are still considered as a single element that lifetime is extended. And accessing a member, for example, is still fine. This person actually had a better approach of this init that was introduced here. There is a copy. Here is actually better. It's actually an R value reference that is being extended. It's actually a better approach. And it says use the new statement with this all the time. This gives a false sense of security because you can do the same mistake if this is fine, but f.g, if g returns another thing, is not okay. Okay, you have this range because g is a function. So you already see the pattern here. If you have a temporary that function and subscript operator is a function, this is not good. It's not going to extend. But if you have a dot v in this case, which is just accessing a data member, this is fine. So you already see the pattern, and just remember this, and it's going to be easier for you to spot all kinds of lifetime issues. And here I took the solution of taking this as a auto ref and putting it here. You can see it here. This is the one thing that is important. F is bounded to we're going back to the quiz where with MSVC. So you can see here that it's a non-const R value reference that is binding, and this is guaranteed to be extended all the way to the curly braces here. Guaranteed. Now that it's extended, I can do a thing, that operator, which is a function, and keep it here. Okay? No need to have a const. And everything from this part holds very nicely later on. So this is a syntax that we have in C++ 17. It's an excellent syntax. We have it for for loop. We have it for if. And I think C++ 20 added it to other, I can't remember exactly, maybe for while, I can't remember, or maybe for switch. I can't remember. I need to Google for that. I can't remember exactly. That's another, I already explained that, so this is fine. And I explained that as well. Members, accessing that members works. And I explained this one. And I explained this is not gonna work because you are back to square one. This is fine. But if you want to do that G, F is a returns a temporary, that G is not gonna help you at the end of this semicolon, the end of this expression in the semicolon, F is gone. G, if G returns a reference, it's a reference to something that already died. And this one, I actually wanted to show what happens if you don't have a ref, it's just a copy, which is also kosher. It's fine, just a copy. It's less performant than the other one. And I also wanted to show what happens if you have const. So if you have a const reference, again, it's fine because we can bind a temporary to a const reference. In MSVC, we know today that it's even non-const reference, but don't do that. And everything also works. So there are a few options here to solve it. All of them are fine. It depends on the use case. Okay, so this one is the last one that someone is asking. And this is why basically the last thing that I want to show. Someone asked, okay, this person refers to the other Stack Overflow question that I mentioned. Said, okay, Barry mentioned that this one is fine. Why? What is the explanation? Okay, Holy Black Cat, which I know who's this guy. I think so. Has a very nice explanation about what would work and what would not. Okay, so everything that you do would kill the temporary unless you have parentheses. You have array access which are not overloaded, not a function call. Same here, same deal for the grouping. You have a member access. This is also fine. Ternary operator, also fine. Comma operator, again, not overloaded. It's not a function. Remember, every time you call a function, you lose the temporary at the end of the expression. Also fine. Any class that doesn't involve user-defined conversion. Why? User-defined conversion are functions. i.e., if a.b is bound to reference, the lifetime of a is extended. And by the way, CPP reference has a very nice write-up about what can be extended, what cannot be extended. And in the same Stack Overflow, by the way, the links are already here in the slides. Amir Kirsch, which is this person, had a very nice explanation about what and all kinds of examples that you can go through what is going to be extended and what is not going to be extended. So, for example, lifetime of A is extended when you have a dot member. .str is here. Dot array is here. All this is fine. Let's see what happens here. All of these are extended. Let's see something that is not extended. Here it's extended. Okay, let's see what happens here. Creating this one. That PTR, and PTR is, where is PTR? Where is PTR? Where is PTR defined? I saw it. Is that a struct? Oh, here it is. PTR. Thank you. So PTR and then pointer access with brackets, not extended. These are the rules. It's not extended. Neither for overloaded, which we already know. Overloaded is A, and str is a string, not going to be extended. Ternary operators, we already know from the previous one. Here, ternary operators are extended. So we would see the ternary. So he actually, what he did is binding to temporary is this one. Then paren grouping, not a function call, grouping, fine, extended. Okay, for the next one, he had a struct A, and so member access, fine. Array access not overloaded must be used in array and not a pointer. Okay, so he has this example. Then ternary operator, fine. Comma operator, not overloaded. Again, if it's overloaded, it's a function call. And any class doesn't involve user-defined conversion. Again, why? Because user-defined conversion are functions. So I think this is if you have this kind of burn into your brain, you basically can avoid all this dangling thing. If you feel that this is too hard, move to Rust. It might be easier. Find the bound checker in Rust. If you, by the way, that's it. Do you have any questions? No questions?
Rust or wait until Carbon is more developed.
Oh, Carbon, yeah. or CPP2.
Yeah, from Herb Sutter.
From Herb Sutter. Interesting. By the way, if you have a chance to watch Herb Sutter, you can do it in 1.5 and above. He speaks usually slow, so 1.5 would be decent to listen. It's pretty interesting. The interesting part, first of all, I would recommend you at least take a look at the first 15-20 minutes. He's talking about, so he's from Microsoft, right? And he's the committee chair. And he talks about how the government actually is signaling us as a community to stop using languages or constructs of languages that are unsafe. So C is unsafe. We all know that. C++ is safe in case you know what you're doing. You know what you're doing and you're avoiding the unsafe features. Now, what we actually doing, and we just talked about lifetime, and it's pretty hard stuff, right? What we do is we teach people how to avoid the unsafe. We have tools that are much better than what we had 20 years ago, 25 years ago. We have better tools. We have sanitizers. We have much better compilers, warnings. But what if, so he says, what if we had a front end and maybe a slightly different syntax that doesn't let you write in an unsafe, in a kind of an unsafe manner. And there is one example that actually I really like is that think about array, CRA. So CRA, when you write an integer v and then 10 elements of integers, it's an array. And you pass this array to a function that it's a C function or C++ function that gets a pointer to an int. This information about the size, first of all, the information that this is actually an array is gone. The fact that the array was a size of 10, the information is gone. If you want this information, you need to do something else. You need to pass this information as another argument to a parameter that accepts an integer that tells, okay, there are 10 elements. You pass 10, right? Size of or whatever, right? Okay, but what if we don't allow people to do that? And we have this zero cost abstraction where span is basically is used instead. So the information is not, the information that you have in your hands is not lost because of pointer, if array decay to pointers. So this is just one example. I highly recommend looking at this talk, as that again, at least the first half of it, because he talks about the motivation, that talks about what I kind of extrapolated to what would happen if we not stopped using unsafe features and stop looking at safe features. And I think this is why we see all kinds of new languages. It's an ABI issue. There is a safety issue, and we need to address that because in 10, 15 years, maybe we'll be forced to have to work with safe languages or safe syntax. Otherwise, the CVEs and other exploits that we have today would continue, and software is just getting more and more complex. It's not getting easier. So I think this is a very interesting. It's also an interesting time of the whole evolution of languages. So so take a look at that.
Kobe, just a comment. I'm wondering, is there a role for unsafe programming, at least with regard to the roots of C and machine level programming and device driver development? But that's, so I guess, an argument for C++. Anyway, go ahead. Sorry.
No, I'm saying, so there is always this claim that, okay, for embedded and lower level, we need something like C. I'm kind of disagreeing, and what I suggest people do, take a look at one of the talks that we had in CPPCon from a guy, sorry, I forgot his name, that works in Amazon Prime Air. So the drones that they develop for Prime Air, and they're using C++ for the drones. Jim, you would be interested in that. And he's saying, okay, we're using C++, but here's the issues that we have. We can use the standard library because it's doing allocation, and we can't do allocation. But anything else, like strongly typed, and people ask, like, why don't you use C? Say, I don't want to use C. I want something that is much more strongly typed. I want const expr. I want maybe templates. I shy away from the dynamic allocation, but that's fine. We can do something without. And you have a lot of good libraries, C++ libraries that provide something like the standard library, templates, containers, and so on, that don't allocate. They are designed for embedded. I can remember from the top of my head, but GitHub has a few which they have lots of stars. So there are solutions, and it can be written in C++. And a lot of things that you write in C++, if you know how to write it, it's going to be generated the same code. And I have a lot of examples to show. Maybe in debug, no, but when you move to optimization, you turn on optimization, it would look like how C was compiled and the code was generated. So there is, I think there is room for that. I think the government might one day say, okay, we can't really deploy unsafe software. There is this, I don't know if you know, but there was in the past 24 hours, the CTO of Amazon, what was that? AWS? I can't remember. There's a CTO of some big company that says C++ is unsafe. We're not using it. Now, I know Amazon is investing a lot in Rust, so who knows? But I can definitely see his point when he says it's not safe, because I review code that I see that use C++ and it's written in a very unsafe way that I'm not blaming other people saying, okay, this is unsafe. Like I can't really blame people. It's really hard to teach, and this is what Herb Sutter is saying. And so, okay, instead, I'm providing a front end and I'm providing you a syntax that you can't really do wrong. Like you can't really use a variable before you initialize it. Just this language doesn't let you do that, but the C++ let you do that. C let you use an uninitialized variable, but it's an undefined behavior. The compiler can do everything, right? So what if you have a language that doesn't allow you to do to dereference something that was uninitialized? So these kind of things, I think, are very good ideas, and I think this is the direction that the industry would go to. Maybe it would take 10 years, maybe it would take 50 years, but I think it's something that eventually would happen. Any other comments or questions?
Again, I have not used Rust, but I believe there are unsafe programming practices in Rust also, right? There's a safe Rust and there's an unsafe Rust.
Yes.
So it doesn't get you completely away from making these choices on a day-to-day basis about your programming choices, right? I mean,
yeah, it needs to be minimized. Yes, and I wish we had here someone from Rust community or someone that is really there is. I can remember there are guidelines about when to use unsafe clause, but it should be minimized. It should be self-contained in the sense that it's. But yeah, there are some people from the C++ community that when you put Rust on the table, they say, yeah, but there is this unsafe, and when you need to do some crazy stuff, some more fancy stuff and references to all kinds of stuff, you fall back to unsafe. And what's the point of that? And I'm not doing enough for us to defend any of the approaches. So so sorry about it. But it's definitely true that there is an unsafe part of Rust. Okay, thank you everyone. Sorry for the glitch before. Blame it on my computer. Hopefully you have a good rest of your week. And good weekend.
Thank you, Kobe.
Thanks.
Thank you, Kobe.
Thank you.
Thanks, Pat.
See you.